Alrighty, we're going to go ahead and get started. Thank you everybody for joining us today for this joint webinar with MecSoft Corporation and McNeil & Associates Rhino. We have a lot to cover today, so we're going to go ahead and get started. First of all, the title of our webinar is Freeform Modeling and Machining Using Rhino plus RhinoCAM. And just a little bit about MecSoft. If you've never heard of us, we've been in business since 1997, and since then we've been developing CAD/CAM software for the CNC machining industry. And our software comes in several configurations, and that's anywhere from 2, 3, 4, 3+2, and 5-axis milling, as well as 2-axis turning. And you can find our software as standalone, where you don't need any other third-party software to run it. And then our software is also, you can buy it as integrated plugins, and it's integrated into Rhino, of course, SolidWorks, and Geomagic Design, which is formerly a Libre. And a little bit about Rhino plus RhinoCAM. This is our elevator pitch, so to speak. Our software is best-in-class surface modeling and machining. And one thing that we really take pride in is that our software is very easy to learn and use. And that's something that in research and development that we take very serious, is making our software very simple and user-friendly. So another big thing that we take pride in is our outstanding customer service and support. We have get testimonials all the time telling us about they're thankful for our support. You can see there in the bottom is a recent testimonial. So that's something that you'll find as a MecSoft customer, is our outstanding support. And you're going to hear from Uday, who is our technical support manager here at MecSoft, and you'll see that the level of quality of support that you get as a MecSoft customer. And last but not least, why Rhino and RhinoCAM? It's affordable. You'll find that the value that you get with both of these software products is definitely unmatched. So today's webinar, you're going to hear from a couple different people. First off, after I give this brief introduction, and I just realized I did not introduce myself. My name is Tim Streifler, and I am the marketing coordinator here at MecSoft Corporation. And joining me today, I have a few of my colleagues, a few other members from the MecSoft team. I have Anita Anand, Enrique Romero, Scott Dixon, and Uday Hanalajiri. And if you guys want to say hello to everyone real quick, unmute yourselves.
Hello, everybody.
Okay, that works. And then we also have Scott Davidson joining us from McNeil & Associates, which is a developer of Rhino. Scott, if you want to say hello to everyone as well.
Hey, everyone. Glad you guys are all here.
Alrighty. So first off, in a minute here, I'm going to transfer it over to Scott as he gives a introduction to Rhino and shows you a little bit about Rhino. And then after that, we'll move on to Uday, who will give a demonstration in RhinoCAM, and then we'll finish the webinar with a question and answer period. So if you have any questions throughout the webinar, please send them in the question and answer, or sorry, the question panel, which is in the user interface of the GoToWebinar system. Ask your questions in there, and we'll do our best to answer them throughout the webinar. And then from those questions, we'll answer them out loud for everyone to hear at the end of that question and answer. So we might not be able to get to every single question. If we don't, we apologize. We will be able to post those questions in a blog post later. So you will get your question answered. It just might not happen today during the webinar. And so a couple other things. I mentioned it before we got started, but the webinar will be recorded. And so it will be live on the Mexoft blog as soon as tomorrow. And so you can find that recording, mexoft.com/blog. And I posted the link to the direct post in the chat. So on the bottom of the GoToWebinar panel, you should have that link there, and you can copy and paste that and save that. So if you have to cut out today and you have a busy schedule, don't worry about it. You will be able to watch that recording at a later time, and we highly recommend it, in fact. So the last thing I'd like to mention is, if you're not already, follow MecSoft on Facebook, Twitter, and YouTube. And the links are there: facebook.com/MecSoft, twitter.com/MecSoft, and then youtube.com/MecSoft Corporation. We tend to give product sneak peeks, as well as we announce webinars such as these on our social media channels. So to be able to find out about those first, that's typically the best place to find them. So if you go ahead and like us and follow us, then you'll get notified about what's happening before anybody else. So let's begin. I'm going to go ahead and change the presenter over to Scott Davidson. Scott is he's with McNeil & Associates, and he's been working with Rhino for 20 years at McNeil, supporting and marketing and helping customers get Rhino to work. So he's a market developer for Rhino. So I'm going to go ahead and change him as the presenter. And so without further ado, Scott Davidson, the floor is yours. Scott, I think you might be muted. I don't hear you yet.
Yep. Hey, is that better? So,
yep, hear you loud and
welcome
clear.
everybody, and thank you, Tim, for the introduction. Thank you. And glad everybody's here. And so today I was going to cover a few things about Rhino, kind of review how Rhino is being used, some sample projects, talk about a quick review of some of the existing features, not at all comprehensive, but some of the features you might find useful. For existing customers, it might be a couple commands that you haven't really either looked at very closely or maybe don't realize how they might be useful to you, and so we'll go over those. Also do a quick review over Rhino 5, just touch on a few points. That's our new version that we just came out with this spring, and really start to look at how that might be able to allow you to move forward with what you're doing. So let's start with Rhino in general. Rhino is a NURBS surface and solid modeler. It is used in a lot of different ways, in architecture, product design, in automobile design, marine industry, movies, jewelry. And the reason that Rhino is used in so many different places is that it has a few features, or a few kind of, there are goals, but there are a few kind of strengths that we look at. The first thing is that we can do very sophisticated freeform shapes. We can really model any shape that you can think of, and that flexibility allows you to design a lot of great objects, but it also allows you to import and work on a lot of different geometry types, and that's something that you'll find a lot when you're working with other people, is the ability to bring in a lot of different types of geometry and work on it. It's extremely accurate. It's accurate enough to manufacture directly from. It's compatible with a lot of different products, and we'll talk about that a little bit. You can use it to read and repair very challenging files. Rhino will take in files that are essentially corrupt, and it will allow you to repair those, to put those back together so that you can actually work. It's easy to learn. It will work on just about any computer that you can get your hands on, and it's affordable. So one of the things I wanted to review was how just the different scale of projects that Rhino is being used on, just to give you a good sense of as you're looking at what your workflows are, about how Rhino might be able to help you in those places. This is one of my favorite projects. This is Sagrada Familia in Barcelona, and it shows you kind of in a grand scale the ability for Rhino to design, in this case where they're reverse engineering plaster models into Rhino, and then they use that data to actually fabricate the building itself, a lot of the formwork, using CNC equipment, hot wire cutters, whatever they can use to create the formwork for a lot of the masonry that they're working on. Another example is a little bit smaller scale, is this indoor skate park. Thought this was interesting in that they not only designed the outer shapes in Rhino, they used Rhino to figure out the structure underneath and figure out all the pieces and parts. And they also used some tools within Rhino to unroll the compound shapes so they could figure out how to cut the stock out, the plywood in this case, in order to create the curved skate park shape. Furniture is very popular with Rhino. A lot of that is because the shapes can vary from very traditional shapes to modern shapes to organic shapes. It can be used with different materials, obviously, and so again, you know, this ability to be flexible and this ability to design any shape and to use any kind of combination of fabrication and material is something that Rhino's used a lot in. And the smallest scale of objects that we work on or that we see worked on is the jewelry industry. The ability to design very complex organic shapes and again get it fabricated through multiple different output methods, and that's something that we're seeing more and more of. So if we look at some of the other ways that you can work with Rhino, we support a lot of input methods of inputting. We can bring JPEGs in. We support a lot of different scanners, whether they're touch scanners or point scanners. We can work with that data if you're doing any kind of reverse engineering or any measurement. In addition to input, a lot of different input types, we also have a lot of different digital fabrication methods we support, whether it's robotic arms, traditional CNC kind of cam. We also can be used to output to rapid prototyping machines or plasma cutters or water jet cutters. And so there's a broad range of fabrication techniques you can use coming out of Rhino. And so again, that flexibility of bringing in many different file types and outputting to different methods. And many projects, or some projects you have, may use multiple methods, and that's something that Rhino supports quite well. The file, as we move forward with file import and export, we've really worked hard on supporting a lot of different file types, and so there's a number of file types that have been improved in Rhino 5. Some of the ones that you might be interested in with the new version of Rhino 5 is that we have an improved step importer. SolidWorks importer has been improved, new IGES, and much better OBJ import. And so those are a lot of different types of file formats. We've also added the ability to import more files like Collada, GTS, and the ability to read and write PDF files is something that a lot of people are using. In addition, and many people don't know this, you can also buy plugins to read CATIA v5 directly or CATIA v4. You can also buy plugins to read UG files natively if you'd like. And that's something that is available on a resources page up on the website. One of the things I'd like to cover now is to really start to look at Rhino 5, or Rhino in general, and a couple edit tools that we have. With all these file import capabilities that we have, Rhino many times is used to essentially pull apart or defeature a product or get a product prepared for machining. And in this case, we'll take a look at some examples of what I call solid editing. So this is Rhino here, and you can see that it's a plastic part here. And one of the things, it doesn't matter if I built this in Rhino or that if it came from another place, so imported, whatever you bring into Rhino you can edit. That's one of the nice parts about Rhino. And if we're going to machine this a lot of times, we may want to take a lot of the holes out, for instance, and machine in a roughing way, put the holes in the slots in later. So one of the commands, we have a menu down here called solid editing. That was in Rhino 5 or Rhino 4, but it's it's an improved product in Rhino 5. But I'll go here and we can say, for instance, I can come in and if I can, we have different things I can, for instance, I can come in and I can delete these slots if I want. So it'll go and you can see that it repairs, not only deletes the slot, but it puts the original surface that was underneath it is also put back together. So now you have a smooth surface. If I want to, in Rhino 5, if I want to come here and I can duplicate, let's say I actually want those curves for later, but I don't want them in the 3D model, I can duplicate the edge. Let me duplicate both these edges. And so what that'll do is that creates a curve there, and then when I delete these holes, you can see what it does is it will delete the holes, but it does keep the curves here. And so those curves I can use for a machining operation later in the process. This delete hole capability also has the ability to, for instance, delete holes like that. So you can quickly repair and work on models that you import from Rhino or from other places, and start to put the model back together in a way that you can actually machine it, and then you might come back and do these things later. Another more sophisticated way of editing models. This is a guitar body that was imported, and we have the capability of copying holes, for instance. So if I want to grab this hole and copy it, so I want to add another pickup in this case, I'll copy it there, and let's put it right there. You can see that it copies the whole hole, the depth. It puts it back into the model. We can also change the objects. Let's say I want to move a face. So I might take these two faces here, and we may want to make those pockets a little bit deeper. So you can see here that I can type in a distance, or I can create a different, and that updates the model quite quickly. So the ability to edit solids, the ability to change an existing model. Of course, this is Rhino, so I can explode this into its surfaces, and I can edit those surfaces also, and really give you the ultimate flexibility of being able to interrogate the model, pull the model apart in a way that you can get your machining done any way that you need. Another set of commands, so that's really the solid editing tools, and I highly recommend exploring those with your own models. Another set of commands that's used quite a bit, a lot of people don't know about, is called curve booleans. And curve boolean is the ability to search an area and find outlines and borders in order to, for instance, either use as a tooling path, or to use it as a controlled region if you want to limit the tooling to a certain area. So we get to curve boolean by going to the curve pull down, curve from objects, and it's going to be curve edit tools actually. Curve boolean right here. And so curve boolean will work on multiple, on 3D objects as well as 2. So I just select all those. And what it allows me to do is pick in an area, and it will flood fill. As you can see on the screen, there's a lightly shaded area. It'll flood fill that area, and it'll make an outline around that area. What's fun with curve boolean is if I continue to click in areas, it will add them together. So if I want to get a quick outline of this guitar shape, in order to use it in machining operation. You can see that I can quickly get a nice outline. That's the 2D outline. It's completely closed. It's very cleaned up. If there's any overlaps or any small loops in the curve, this curve Boolean command will take that out. So I can quickly grab that outline, and I'm going to move this off to the side so that you can see that I can get that outline. And that's a nicely cleaned up duplicate of that outside edge, right? I didn't have to take a section. I didn't have to. There's a lot of other ways I could try to, I guess, capture that edge, but this is the quickest way to do it. Nice part about curve Boolean is if I want to take another set of curves off here, let's say that I want all the pocket outlines, I would just grab it and I click in each pocket. And what it'll create is a set of pockets for me. And again, these are 2D curves. They're cleaned up. So you can see, for instance, this is a great example. Right up here, this is a nice 2D outline. Could be used for pocketing quite well, although it came from a much more complex set of curves. And so our curve Boolean cleaned this up, created a 2D outline, and put it together for me very quickly. We use curve Boolean for a lot of different processes. If anybody does any kind of inlay work and gets artwork from Adobe Illustrator, or it gets a lot of complex artwork and needs to work on inlay patterns, curve Boolean is a great product or a great command to pick different areas of the inlay and allow you to create closed outlines to cut the different inlay materials. Another area that I don't know how many people have run into, but we see it quite a bit on technical support is the ability to use TrueType fonts in 3D modeling. TrueType fonts, when you're using fonts, are very, very poor geometrically. They have a lot of overlaps, they have a lot of small loops, and you'll find you'll have a lot of problems using them in trimming, creating solids, Booleans, all those types of things. TrueTypes can be terrible that way. And curve Boolean is a great command to, as soon as you make the curves for the TrueType, go through it with curve Boolean, pick inside every letter, and it will clean up the overlaps. It'll clean up the small little loops. It'll clean up that geometry, and you will find that it will work much better for 3D modeling further down the road. And so we use it for finding outlines. We use curve Booleans for inlays, and we use curve Booleans to fix font curves quite a bit. So those are some areas that we use curve Boolean. So, so let me just jump back in. Another area that Rhino is very good at, and it benefits with RhinoCAM and Rhino together in this case work quite well, is Rhino can import STL files. It can import now PLY files. You can import mesh files, OBJ files, and we can actually edit those. We can repair them. We can analyze them. And we can machine with RhinoCAM. You can machine those meshes directly, and so it avoids the need to have to try to convert it to a NURBS, convert it to surfaces, which can be time-consuming and sometimes not possible. And so with Rhino, we have the ability to also work on meshes, not just solids, not just surfaces, and that's something that really can open up your toolbox in terms of being able to get your work done. Right? So those are kind of some of the things I wanted to talk about in terms of, what we see people use Rhino for a lot. I want to talk really quickly here about Rhino 5 and what's new, some of the points with Rhino 5, things that you might find useful getting your work done. The first thing with Rhino 5 is Rhino 5 is our first true native 64-bit app. It does come as a 32-bit application, but we now support 64-bit, the 64-bit memory space also. This also extends to the plugins, and so if you, in this case, had RhinoCAM for 64-bit and Rhino 5, these memory limits are also going to expand for you. So if you look at a 32-bit platform, for instance, Windows 7 32-bit, the operating system can can access 4 gigabytes at a time. And that can be quite limiting as your models get larger and larger. And I'm sure many of you that have used Rhino 4 and have seen that you can run it out of memory quite quickly. With Rhino 5 64-bit and, for instance, Windows 7 64-bit, even just the home premium version, you can already start to access 16 gigabytes of memory. If you have Windows 7 64-bit Professional, you can access 192 gigabytes of memory. And with Windows 8, we're getting up to 512 gigabytes of memory that we can access all at the same time. And this essentially allows that memory space to be unlimited. There's other things that probably fail in the process before you run out of memory now. And so that's one of the big improvements to Rhino 5 is just the ability to work on much, much larger models because we can now go to 64-bit. And that will also apply to RhinoCAM and its ability to deal with much larger machining operations and much more sophisticated or smaller stepovers and all those types of things that previously we might have run out of memory on. So let's just jump into Rhino 5 to look at some of the other improvements that we have. Rhino 5, you can see the interface has changed slightly. It now has toolbars or toolbar tabs across the top. It also has the ability to have panels over here on the left, or I'm sorry, on the right. And so this is properties now is up, and in this case layers. And there's many more panels that you can have up real time, and of course RhinoCAM will add to those as we watch Uday's presentation today. Another area that we've improved. Let me just change the model here, is we have the ability now what we call a gumball manipulator. And so with the gumball, what you can do is you can pick on an object, and you'll see here, let me get in a view that might make sense. You can see here that I get a manipulator that I can quickly change the orientation of this object. And so I can, let's rotate it here if I want to just quickly rotate it, get it oriented for machining. I might want to move it up and down, so I can just grab the Z-axis and I can move it straight up and down. And I can also rotate it on any axis I want just by grabbing it and rotating it. And that's available for all objects in Rhino. And so that's a nice addition. You can quickly edit objects and move them around and transform them quite quickly. Another area that we've added that many customers have been asking about for quite a while is the ability to do shelling. And so with Rhino as being kind of at its core a surface modeler, it's always been difficult, for instance, to thicken an object or to take an object and hollow it out. And this is something that we've added and improved on as we move through the Rhino 5 cycle here. So here I have a model that is a surface model. It's open to the inside. This would work on a fully solid model too. But I can go to solid, what we call a solid offset. So it's right there. And this will offset the surfaces, but it will restitch all the interior surfaces back together. It will actually create, it'll close off the edges, and it will create a thin-shelled object. So I'll go to offset here, pick the solid, or the polysurface in this case. It asks me the direction. I'll just click on it to reverse the direction. I can go and I can control what the corners look like. I can control whether it wants to be solid. In this case, I'll give it a distance, small distance, and then we will let it work on that offset. And so this is a process that previously anybody that's used Rhino 5 or Rhino 4, you could do offsets of all these surfaces, but it wouldn't actually be a solid at the end. It would just offset the various surfaces, and you'd have to go and manually clean up all the little surfaces and things like that. In this case, you're going to see that Rhino did all the offsets and closed the edge and goes through and actually cleans up this whole model. So now this is a solid for rapid prototyping, or you can machine the interior, take a section, And that's a very important new feature. This works for both surface models, polysurface models, and it also works for meshes. So if you want to thicken a mesh model that you've received, we can also do that. Another area that we've improved quite a bit is Rhino's ability to do display modes, various display modes. You can see that we have a number of them in here. Shaded mode, ghosted is from previous versions, but now we have the ability to do, let's say, a technical mode. So you can see as the screen catches up, this ability to see hidden lines in the model. This is a working mode, and so I can actually work in this mode. I can also come in here. For instance, we have an artistic. So this is the ability to look at the object in an artistic mode. And we use this a lot to quickly visualize the parts. And you can print these out, of course. You can capture these and do a screen capture for high-resolution screen capture and send those off through emails and different parts. We also have the ability to do a pen mode, so the ability to have something look like it was sketched with or drawn out with a pen. We can get more and more sophisticated with these modes now, and for instance, this is a mode that you can actually download off the web. We have different styles you can download. You can experiment yourself. But this is a patent drawing style mode that you can see here on the left, and that's something that, again, it's a working mode, but you can use it also to print and to copy. And then the rendered mode the real-time render mode has gotten more and more sophisticated. So I have the ability now to do multiple materials, do reflections, do bitmaps, and that mode is actually a working mode, but it's also a real-time rendering mode, so that you could actually print this out and see that on the screen. And that's something that with Rhino 5, in terms of presenting to other places, that's something we've improved. The last feature I want to show you, or not show you, but the last feature I want to talk about is the improvement in Rhino 5 to drafting. So we have more and more capability of doing 2D drawings. We have more annotation styles. We have more control over dimensions. We have revision clouds. We have more layout controls. And we also have printer calibration for those customers who have been trying to use the printer to plot out full-scale patterns, for instance, or you want to do longer plots. We have the ability now to calibrate the plotters so that you can get an accurate output in your capabilities. So if you're doing shop drawings, so now you're hopefully in a position where with Rhino you can import your models, you can repair them, you can prepare them for CNC work, you can do the CNC work, and in addition, within Rhino, you can do your shop drawings. And so now you're in one product using Rhino with RhinoCAM in order to do more of your workflow. So that's what I have for you today. Thanks for putting up with it for a while, and I'll be around for questions after Uday does his presentation, and we can talk more about Rhino 5 if you'd like. So thank you very much.
Alrighty, thank you very much, Scott, for that in-depth look into Rhino and Rhino 5 specifically. So before I introduce Uday, I wanted to mention, if you're joining us, if you're just now joining us, you can ask questions about the anything to do with Rhino or RhinoCAM in the chat, which is located in the GoToWebinar interface. I believe it should be the bottom right-hand corner. So if you have any questions, feel free to ask them there, and we'll do our best to get those answered for you. So our next speaker is Uday Honolajiri. He is the MecSoft Technical Support Manager, and he's been with us since 2005. He started out as an application engineer and has since moved up to our support manager. So Uday has a MS degree in industrial engineering from Arizona, and he majored in CAD/CAM. So without further ado, Uday, the floor is yours, and so go ahead and share your screen, and we'll get started with the RhinoCAM portion.
Tim, thanks for today. Scott, thanks for the nice overview of Rhino 5. Folks, good morning, good afternoon, or good evening to you from wherever you joined. I'll be giving you a presentation of RhinoCAM. RhinoCAM is fully integrated into Rhinoceros. It can be used for machining solids, surfaces, STL, and STL or polygon mesh geometries, and you can even work with just 2D drawings to program toolpaths in 2 or 2.5 axis mode. So having said that, I would like to go ahead and use this guitar example where we can generate some 2.5 axis toolpaths with RhinoCAM. Now once you start up Rhinoceros, RhinoCAM automatically loads up in Rhinoceros and is available in both 32 and 64-bit versions of Rhinoceros 5. And RhinoCAM menu bar shows up right at the top of your screen under Rhinoceros, and you have access to your machining operations browser and the machining objects browser. Now the machining operations browser shows up over here to the left half of the panel in Rhinoceros and is docked by default. You can have it moved around, you can dock it anywhere, or you can have the window floating in here. The machining objects browser appears right below the machining operations browser, and it has 3 tabs. You have the tools, the machining regions, and you have knowledge bases, and we'll try to talk about these as we go through the presentation. The tools tab allows you to manage all your cutting tools. You can define different types of tools in RhinoCAM. You can define ball and mills, flatten mills, corner radius tools. You have tools for engraving, chamfer, taper tools, thread milling, face mill. You have specialized form tools like dovetail cutters, fillet mill or corner rounding tools, lollipop cutters. You can also create form tools in RhinoCAM where you can actually draw the profile of the tool in Rhinoceros and define it as a tool. And of course you have the drill, center drill, reamer, tap, bore, and reverse boring. Now for each of these tool types you can specify the tool properties, and as you update the tool geometry, the previews for the tool are being updated. You can also specify the tool material type, the tool number, define the coolant type, and you can also have the feet and speeds assigned for each tool. Now we also have a feet and speeds calculator in here which would help you determine the feet and speeds based on the material that you're working with. And this material list can be edited and customized to add more material types to it as well. Now in here, in this example, I have a library of tools loaded. You can load the default library of tools that's included with RhinoCAM, or you can build your own library. Now under the Program tab, we have 3 different groups. We have the machine setup, we then have the start, and then the machining operations. So we'll work our way left to right as we work through each of these groups. The first thing we would like to establish or define is the machine tool. So I'm going to click on the machine tool setup dialog and specify the machining type, the number of axes. For this particular application, since the part we're trying to program is prismatic and we would like to just machine it from one side, I'm going to set the number of axes as 3. RhinoCAM can be used for programming 2 to 5 axis applications. We have 2 axis or 2.5 axis, full 3 axis, 4 axis indexed and continuous machining, and we have 5 axis indexed and continuous 5 axis machining available in RhinoCAM. So I'm going to select the machining type as 3 axis, and this information is automatically updated in your machining browser right under the machining job. In the next step, I would like to go ahead and select my post processor. So this will be the machine tool that you're going to be outputting the posted G-code to drive your machine. So RhinoCAM includes over 220 plus different posts, which covers a wide range of CNC machines that are out there. You can select the post from the list of posts that are included. For this particular demonstration, I'm going to select the post processor Haas, and I can also customize or modify the post with the inbuilt post process generator that is included in RhinoCAM. So you can specify your startup block, program end block. If you need to make changes to your tool change, macros, all of this information can be updated right in the post processor. And then you would also want to specify your posted file extension. Typically for most controllers it would be .nc, or you can specify your own format for extension. You can say add new, and you can select the new extension format right in here, specify it. Now the information for the post processor has also been updated in the machining operations browser. In the next step, we would like to go ahead and establish the stock material for machining this part. So I'm going to go to stock under the stock group and select box stock. There are several other types of stock types you can define. So if you're working with the casting, you could do a part offset stock, which would create a true 3D offset of it. You can do a stock by extrusion. You can also model your stock or import a stock, a 3D geometry into Rhino and use stock from selection. So for this application, I'm going to use a box stock, and RhinoCAM automatically analyzes the extents of the part that's modeled in Rhino and gives you a minimum stock dimensions that's required to program this part. I'm going to change the length of the stock to 20 inches. I'll update the width to 15 inches, and I'm going to leave the height as 1.5 inches thick. I'm going to go ahead and click OK to accept it. Now the stock geometry has been defined, and I can click on the stock visibility in here to have the stock model displayed around the part. In the next step, I would like to align the stock to the part material. So I'm going to go down to the Align menu and select Align Stock. I'm going to have the stock aligned to the top face in the Z, so have it flushed with the top of the workpiece, and then have it centered in X and Y. I'm going to go ahead and accept that. We will now establish the work 0 or the program 0. So I'm going to use Align and click on Set World CS to establish the world coordinate system. I'm going to choose Set to Stock Box, and now I have an option to specify the 0 phase. I can either pick higher Z, mid Z, or lower Z, or I can even go down to the pick option and snap to a point on the model in Rhinoceros. So I'm going to use Set to Stock. We'll do higher Z for the 0 face, which would be the top face of the workpiece, and I'm going to use a southwest corner, which would be the lower left corner for the XY origin, and I'm going to click OK to accept it. Now you'll notice that the part and the stock are automatically being transformed, and the origin is set to the southwest corner, as you can see it in the top view, and then to the top of the material, as you can observe it from the front view. In the next step, we would like to go ahead and establish the material that we're going to be using to machine this part from. So I'm going to click on the material button in here under the stock group and select the material type. So for this guitar body, I'm going to use wood as the material, and as I select the material texture visibility, you will notice that the material texture is now applied to your stock. I'm going to switch back from the Simulate tab back to the Program tab, and we are now ready to program this part here. We have a few pockets, and we would like to cut the profile around this body of the guitar. So first, I'm going to go ahead and select 2-axis milling, and it offers a wide range of methods. We have facing, pocketing, profiling, we have V-carve roughing and finishing, engraving, chamfering, hole pocketing, thread milling, T-slot machining, and remachining under 2 or 2.5 axis milling. I would like to program the 2 pockets in here, so I'm going to select pocketing, and the pocketing operation dialog shows up, and we would now like to specify the machining features that we would like to pocket. So I'm going to use select drive containment regions from the machining features tab, and I can select either curves, or I can even select surface edges or face edges from the surface model or the solid model in Rhinoceros. So I'm going to use select curve from the selection menu and add these 2 curves to my selection. Once I have the curve selected, I can do a right mouse button click or press enter to accept the selections in here. So you can do remove all to add new selections, or you can go back in here and select curves, or I can pick surface edges. So I can do the curve selection from either the top or from the bottom of the pocket. So once you have the features selected, you can go to your tool definition to grab the tool. I'm going to use a 1/4 inch end mill. Go to feet and speeds, specify the feet and speeds. I can load them from the tool, or I can use load from file to have it automatically load the feet and speeds from the file based on the stock and the tool material. Now the clearance defines your safety plane for your transfer and non-cutting motions. We can specify this to automatic, where RhinoCAM automatically figures out based on the part and the stock geometry. And then you can go to your cutting parameters, where you can define your tolerances for pocketing, your stock elements. You can choose your cut pattern. You can do offset, linear, spiral, or radial cuts. You can choose your cutting direction, specify your step over. Now under cut levels, you can actually specify the total depth. So you can say you want to pick the start of the pocket. I can snap to an endpoint on the surface model. I can also measure the depth. I can grab the depth by just snapping to 2 points, one at the top and the other one at the floor of the pocket. Now I can specify my depth per cut. I can cut it in multiple passes. I can specify my entry and exit from the entry and exit tab. This would be your lead in, lead out. You could do a ramp or a little entry for the pockets, and then selecting generate will actually create your toolpaths. Now once the toolpaths have been programmed, you can go ahead and run the verification of cuts in here to run the simulation for it. So we can switch over to the Simulate tab. To run the verification. So I'm going to pause the simulation in here, switch back over to the Program tab, and now I would like to go ahead and program the profile for the outside features on the model. So to do this, I'm actually going to go into Rhino to go define a curve using the curve Boolean command in here to extract the curve from the outside edge of the part. So I'm going to go up to Curve, use the Curve Edit Tools, and use the Curve Boolean command, and I'm going to go basically drag a window to select all of these geometries, the surface geometries, and I'll go accept it to create an outline on the entire part. I'm going to accept that. Now I'm going to establish a profile operation in here, so I'll go up to 2-axis milling, select profiling, and I'm going to go grab this curve we just defined using the Curve Boolean command as the machining region for the profile operation in here. I'm going to specify my tool. I would like to use the 1/2 inch end mill for this application. Specify the feed speeds and clearance. Under the cutting parameters, I can choose the cutting direction as climb, conventional, or mixed. I would like to use the cut start side as outside or inside, or I can even do determine 3D model, where RhinoCAM can automatically figure out the cut start side based on the 3D model. Now for the cut levels, I can specify the total cut depth in here. It's going to be 1.5 inches, or I can snap it by picking 2 points in the model. I can specify the depth per cut.
Excuse me, Uday.
We'll do a 1/4 inch per cut.
Sorry to interrupt. Your screen has actually frozen. We can still hear you fine, but we have a lot of attendees that are saying your screen isn't updating. It's stuck in just a frozen state. Okay. It looks like it's working now.
Okay. Well, thanks for letting me know.
Yeah, sorry about that. Okay. All right. Sorry about that, everyone. It looks like the screen is updating now, so everything should work okay. All right. Okay. Continue, Uday.
So I just used the Curve Boolean command to extract the curves from the surface model in Rhinoceros, and I've selected this curve as my machining region, and I'm specifying the depth, total cut depth and depth per cut for the profile operation. I'm going to select the entry and exit, specify the lead in and lead out. I can do a 2D entry, 2D exit, or I can do a long path 3D entry, so I can ramp along the path of the curve. I can apply these entry and exit for each of the cut levels in here, and then selecting generate will create a toolpath. So I can hit the toolpath visibility in here, and you'll notice that now the toolpath for the profiling operation is shown right on the model. I can also click on display toolpath levels and look at the toolpath for each cut level. Now you can notice that the entry and exit for the profile operation occurs at this radius corner in here. Now if you'd like to change where the cutter enters and leaves the material, you can either use the Rhino command, which is the adjust curve seam, by going to curve edit tools, and use the adjust close curve seam, and you can actually move the start point over. You can see that there's a little point and an arrow that's displayed, and you can move it anywhere along the curve. So I'm going to go ahead and move it to the back of the model in here. I'll go ahead and accept it. So since the geometry has been changed or modified by changing the start point, RhinoCAM automatically flags the machining operation as dirty and indicates that the machining features have been modified. So I'm going to go ahead and update the toolpath in here by right-click and selecting Regenerate, and that automatically updates the toolpath, and you can now notice that the entry and exit have been modified.
Hey, Uday, could you slow down just a little bit? I think there's a little bit of a lag. And so
Sure,
just so we
I can definitely do that.
Okay, great.
So now the entry and exit have been modified. I would like to go ahead and run the simulations. I'm going to go switch over to the Simulate tab. I'm going to select the profile operation in here and click on the Play button under the Simulate tab and select to run the simulation. So you'll now notice that the material removal simulation is in progress. If you'd like to pause the simulation, you can always hit the pause button in here and click on Simulate to End, which actually runs through all of your simulation. I can switch back to the Program tab, and I can take a look at the total machining time by doing a right-click and Information. Now this gives you the estimated machining time for each of the two operations that you programmed based on the parameters which you specified for it. One of the nice features RhinoCAM offers is a shop documentation, which can actually prepare a nice little setup information sheet. So you can do a right-click and select Shop Documentation in here, and you can specify the file name and choose from one of the two templates that are available built into RhinoCAM, and selecting Save generates a setup information sheet for the two operations that are programmed for this guitar body. And there's your setup information sheet. Gives you information on the tools that are being used, the machining operations. You can print this out and have it ready for the machinist at the shop floor. Also, one of the powerful features that's available in RhinoCAM, the latest version of RhinoCAM, is the ability to save the machining operations to a knowledge base, and this can be used across other parts that you'd like to program. So in this particular example, I'm going to hit Save to Knowledge Base and save this guitar two operations, the profile and the pocket operations we just programmed, into a knowledge base. And I'm going to show you how these operations can be utilized on a different part we would like to program. I'm now ready to post-process these operations out to the machine. So I'm going to select the setup folder in here, do a right mouse button click on it, and left click on Post, and this automatically brings up your Post and Save dialog. It specifies the name of the file, which automatically grabs the part file name that you're working with, and selecting the Post button in here will output your G code and display it in your NC editor. You can use any NC editor of your choice, or you can use Notepad or WordPad to preview the code. So this would be a typical workflow of how you would program a part in RhinoCAM. Now saving this part in Rhinoceros automatically saves all the machining operations that you programmed with the part file. We will now take a look at an example of a 3-axis part. So we'll take a look at the defeatured drill part, which the drill cover part, which Scott Davidson shows us how to modify, edit features on the part here. So I now have this part being loaded in Rhino, and pretty much you can work with any solid surface or mesh geometry that can be imported into Rhino for generating toolpaths with RhinoCAM. So the workflow is very similar to what we programmed earlier on the 2-axis example. We now have the machine tool defined as a 3-axis, and then we have the post processor in here set to a Haas machine tool. I could change this to any one of the other machines. We have a wide range of posts. I can use a FANUC-based controller in here. I'll grab a FANUC OM as the post processor. I could also change the posted file extension if needed. Now I now have a stock model defined for it. I'm going to use the box stock in here selecting the copy model bounding box automatically determines the minimum stock size that's required to program this part. So we'll go ahead and click OK to accept it. And then I already have a roughing operation pre-programmed on it. So this is available from the 3-axis methods. You have a variety of different 3-axis toolpath methods. To start with, we have the roughing, which is most commonly used to rough the stock material to bring it down as close as possible to the finished shape of the part. Horizontal roughing, we have re-roughing methods. So you can use the in-process stock information to create roughing toolpaths so that you can go back and rough areas where there's material being left because of the large radius tool that you used for the previous operation. You have several different types of finishing methods, starting from parallel finishing, horizontal, you have projection pocketing, 3D offset pocketing, curve-based 3D methods like curve machining, between curve machining. We have remachining and pencil tracing methods also available in RhinoCAM. So we've programmed a roughing operation in here for this part. Now in 3-axis, machining regions are used as containment regions to limit toolpath to specific areas. If you like to rough or program the entire part, you wouldn't have to select a machining feature or region. RhinoCAM automatically generates a toolpath for the entire geometry. In the case of roughing, it automatically takes into account the stock, what you define, and based on the part geometry, it figures out the toolpaths for the roughing cuts. You can specify your cut parameters, where you can set your tolerances, your stock allowance, choose your cut pattern. You can specify the step over control, and under your cut levels tab, you could actually specify your step down parameters. You can specify whether the step down needs to be 1% of your tool diameter, or you can set it as distance or even number of levels. Generate, and it processes the toolpath. The toolpath is now displayed in RhinoCAM, and you can click on the display toolpath level and actually view the toolpath as you step through each of these levels in here. Now we can switch over to the Simulate tab, where you can run the verification of cuts. The workflow is very similar, so you basically select the operation that you'd like to simulate, and then go click on the play button in here, and that would run your simulation for the roughing operation. And you can click on the pause and select Simulate to End, which actually runs through your simulation. There's your roughing process. Now once the part is roughed, we will now go ahead and generate some pre-finishing or finishing toolpaths. So I'm going to go and switch back to the Program tab in the Machining Operations browser. I'm going to go over to 3-axis, and we would now like to use a parallel finishing to finish the drill cover. Now for machining features, I could actually select drive containment regions, and I can select the curve that I extracted from the model using the curve boolean command in Rhinoceros. I can use that as my containment region to limit toolpaths. Now for the tool, I'm going to switch over to the Tool tab and select the 1/4" ball mill. I would now like to leave the feeds and speeds and the clearance at their default settings. And under the Cutting Parameters tab, I'm going to specify my parameters for finishing. So I would like to specify my angle of cut. I'm going to use 45, and I'll use a tight step over. We'll do a 10% step over. I can even go tighter. I can do a distance, a % diameter, or I can even do a scallop height. And selecting Generate will process the toolpath. If you want to specify any containments in the Z, or you want to do multiple levels, you can do that. I'm just going to use the skim clearance for the transfer method and generate the toolpath for the finishing process here. Now this is computing the finishing toolpath for the entire geometry, and selecting the toolpath visibility displays the toolpath right on the geometry. So there's your 3D finishing toolpaths. Now any changes or design changes that you make to the model, you can just go back and do a right click on these operations and select Regenerate to automatically update the toolpaths. We will now like to go ahead and run the verification, so we're going to go ahead and switch to the Simulate tab. We will now select the parallel finishing operation we just programmed in here and click on the play button to perform the simulation. So the simulation is being performed in here. You can rotate the model while it's simulating. You can also hit the pause and click on Simulate to End to run through the simulation process. Now there's your simulated part and ready to be sent out to the machine. Now if you'd like to add a profile operation to clean up the part on the bottom edge, you could actually select the curve from the edge of the part and create a profiling. Now for this particular profile operation, I would like to reuse the profile operation I programmed on the guitar body. So I'm going to go over to the K-Basis tab in the Machining Objects browser, and I'm going to go load the knowledge base. I'm going to grab the guitar knowledge base I just programmed earlier, and I'm going to grab this profile operation and drag it from the Machining Objects browser over to the Machining Operations browser. I'm going to define the parameters. You'll notice that all I'm going to modify is the depth and select a machining feature for it. So I'm going to select this curve as the machining region. I'm going to go over to the cutting parameters, and I'm just going to cut it to the finished depth in just one pass, and selecting Generate creates the profile toolpath. The beauty of this is you didn't have to go through the process of defining your tool, your feeds and speeds, so all of the information that was saved in the knowledge base is now loaded back. You can use it for programming parts with the same set of parameters. Now once you have these operations programmed, you can take a look at the estimated machining time. So right-click and Information will provide you the total cutting time based on the tool, the feeds and speeds, and the cutting parameters. And now it's ready to post-process. You just select the operation. You can post operations individually, or you can select the entire set of operations by grabbing the setup folder, and it'll post them in the order in which you have these operations programmed. If you need to reorder these operations, you can just do a drag and drop so that you can do the profile right after you finish the roughing operations, so to minimize the tool changes. And then we can grab this operation, setup 1, right click, and post will post process the G code out to your machine controller. So it's working on post-processing the code, and there's your posted code. And you can also use your NC editor to modify, make edits, changes to the posted code as well. The next example I'm going to demonstrate here is to how to work with an STL geometry in RhinoCAM to generate some toolpaths. Now this is going to be a 4-axis demonstration. So I'm going to go ahead and load this part in here. This is scan model, an STL part. And the part is being loaded. Now this part has undercuts and features that requires to be machined from more than one side or orientation. Now to program this part, I would need to also create some supports for it so the part can be fixtured on your rotary axis on the machine. So I'm going to go ahead and import a file where I actually have modeled some supports. I'm going to use File, Import in Rhinoceros, and I'm going to go import the supports file into the 3D model. You'll now notice that the supports are loaded. This is a polysurface surface geometry. You have a mesh geometry, so you can work with a combination of solids, surfaces, and meshes in RhinoCAM to program parts. In the next step, I would like to load a knowledge base where I actually have programmed a couple of operations in here. So I'm going to go over to the Load Knowledge Base feature in RhinoCAM, and I'm going to grab this knowledge base called Head and open it. Now this actually brings in the information of the machine tool definition. It has a couple of different operations. So in this particular example, we're going to program using indexed operation for the roughing process, and we'll do a continuous 4-axis for the finishing process. So loading the knowledge base automatically has the information on your machine tool as well. So we have the machine type defined as 4-axis, and we have the configuration set to a rotary table. And for this particular application, the rotary table is aligned parallel to your Y coordinate axis. The rotary axis, or the axis of rotation, is along the Y axis. Now we would like to define our stock geometry, so I'm going to use a cylinder stock in here, and I would leave to specify the axis of rotation as the y coordinate axis, and I would like to specify my stock radius as 5¼ inch, and I'll leave the length at 19 inches. And now I would like to generate my roughing toolpath, so we're going to program an indexed operation in here for the roughing process. So we would like to rough it from the top, rotate the table by 180 degrees, and generate a roughing toolpath for the bottom half of the part. And then we'll rotate it back to 0 and generate a continuous 4-axis finishing toolpath. So you can do a combination of indexed and a continuous 4-axis toolpath. Now in this particular roughing toolpath, you'll notice that the toolpaths have been limited in Z to a specific depth. You can actually specify these parameters by going over to your cut levels and specify the Z containment for the top and bottom as well. I'm going to switch over to the Simulate tab and click on the cylinder stock, and to run simulations in 4-axis, we were going to switch over to the polygonal simulation model, which can simulate undercuts as well and simulate from multiple orientations. Now there's your cylinder stock, which is just defined. I'm going to click on the roughing operation and hit the play button to run the simulation. The simulation is in progress. I'm going to pause it and select Simulate to End to run through the simulation in here. So the part is now being roughed from the top half. Now once it's roughed from the top half, we would like to rotate the rotary axis by 180 degrees, which basically rotates the table on your machine by 180 degrees. And I specify the rotation angle as 180. The table is now being rotated. I'm going to go ahead and select the roughing operation and do a right mouse button click on it to generate the toolpath. Now the toolpaths are being generated for the bottom half of this part geometry. Once the toolpaths are computed, you can run the verification by switching over to the Simulate tab. Select the machining operation and click play to run the simulation. You can also pause the simulation and select Simulate to End to run through the simulation. Now the part has been roughed from 2 different sides. We would now like to rotate the table back to 0, the initial position, by using the rotate table operation in here. And then we can generate a 4-axis finishing toolpaths. And I'm going to use a 4-axis parallel finishing in here. Now there are several different types of 4-axis methods that you can use in RhinoCAM. We have facing, pocketing, profiling. We also have roughing, finishing, and engraving as well. Now finish this part in here, we would like to use a 4-axis parallel finishing. So I'm going to generate the 4-axis parallel toolpath in here. I can specify the cutting parameters, specify the cut pattern, the step over, and selecting Generate computes the toolpath. Now the finishing toolpaths have just been generated. I'm going to select the operation and view the toolpath. And there's our 4-axis finishing toolpath for the part. And we've actually contained the toolpath by specifying the low and the high values to limit the toolpaths. We would now like to switch to the Simulate tab. We'll select the finishing operation and click the play button to run the simulation for the 4-axis finishing toolpath. You'll now notice the finishing operation is in progress. You can also pause the simulation and click Simulate to End if you wish to run through the simulation. So I'm going to go ahead and hit the pause button in here. So just to give you the simulated of the cross section of the part in here, and you can actually run through the simulation by selecting Simulate to End. Now once you have these operations programmed, you could select the machining job right in the top of the tree in your machining operations browser, do a right mouse button click on it, and select Post All to post-process all of these machining operations out to your machine tool. Now you can also select your post-processor just before you post-process the toolpath from the list of posts that are available to you. Your posted code will now appear momentarily and shows your rotational axis code for your 4-axis toolpaths. And there's your posted code which shows your rotational axis. So I'm told that one of the attendees would like to see the rotation of the table. Now this is performed using the rotate table setup operations. If you go under the setup, under the program tab, you can select the rotate table setup, and you can specify the table rotation angle, and this is typically used for indexed machining where you can rotate the table to a specified angle and the table is being rotated about your rotational axis. And selecting OK creates a new setup, and you will notice that your coordinate system is now being oriented based on the rotation angle, and you will now be able to program an index machine operation for it. So this is how you define rotate table setups. Tim, this basically concludes my demonstration for RhinoCAM. Back to you.
Alrighty, thank you very much, Uday, for that in-depth look into RhinoCAM. So right now, everybody, we're going to go and do a short question and answer period. We are running a little bit short on time based on the hour and 15 minutes that we scheduled this webinar for. We have no problem going a little bit over, but if you need to log off, that's okay. You'll be able to watch the full recording as soon as tomorrow. Again, you can find that mexoft.com/blog. But I'm going to ask a few questions in here that were asked throughout the webinar that we found important. There's one in particular here. Let's see. All right. Does the finishing process use the rough stock info or just the model? Can break bits of the stock material is too thick? Does that question make sense, Uday?
Yes, it does. The finishing process actually looks at the part info. It is not looking at the in-process stock from the roughing operation.
Great. Next question here. Can I change the color of the stock in the various strategy?
You can actually assign the color for the cut stock, and this would be basically defined for all the operations, but you can actually change the cut stock in between operation and it'll basically apply the new color, but there's basically only one color that's defined for the cut stock.
Great. And how do you set a 0, 0, 0 in space without assigning a stock box?
Okay, very good question. You could actually use the work 0 feature.
All right.
From the program tab, and you can actually specify your 0, 0, 0 in space, or you can actually enter a coordinate in here. So let's say, for example, I want to put my 0 at 10 inches in X, Y, maybe 5 inches in Z. And so specifying that and clicking generate establishes your origin. That would be the 0, 0, 0 for machining.
Great. And next question we have, are there any recommended resources for tool parameters? Like
I'm sorry,
speed.
I was not clear on that.
Sorry, let me reread that for you. Let's see here, lost the question there. Are there any recommended resources for tool parameters like speed for a material?
RhinoCAM includes a feed speeds calculator. If you go into your tool definition, you can go under Feeds and Speeds tab, and you could select the load from file, and RhinoCAM will be able to give you a recommendation on the cut feed rate and the spindle speed based on your stock material, tool material, your surface speed, and feet per tooth.
All right. There are many types of operations. How does one choose the best one?
This
might be a little bit of a loaded question, right?
That's right. Well, there's a, based on the geometry, it could be whether a 3-axis or 4-axis, or if it's a, part that requires just prismatic, it needs 2-axis, 2.5-axis programming. So there's a lot of help files and tutorials that are available in RhinoCAM you can refer to, and you can learn about, what kind of operations can be used for, a specific application.
Great. All right. Moving on to the next question. Can you modify existing posts to accommodate a twin table with twin spindles and ATC on both spindles? Want me to reread that question?
Sure. Thank you.
Okay. Can you modify existing posts to accommodate a twin table with twin spindles and ATC on both spindles?
We currently only support single spindles. I don't believe we currently do multi-spindles. That's something I would have to check and get back. But the post processor can support machines with ATC and non-ATC, automatic tool changers and without automatic tool changers. But I don't think we currently support multiple spindles.
All right. A couple more questions here. When you change the RMP in a tool feed speed, does it update the feed rate?
Just modifying the spindle speed in the feeds and speeds dialog in your tool definition does not update the cut feed rate. If you update it in your feeds and speeds calculator under your load from file, that would update your cut feed rate.
All right. So we're going to do 2 more questions, running out of time here. Can the tool wear be programmed? Is there an easy tool wear program tool in the program?
Are they referring to like a tool wear for a color compensation? If that is the case, in 2-axis operations, we do have the ability to turn on compensations and like profiling, pocketing, and facing, where the tool where it can be compensated at the controller, and we can output a cutter compensation left or right. It could be a G41 or a 42. Now, if it's going to be a 3-axis operation, the user can actually program the tool, define the tool in RhinoCAM with the actual tool diameter by modifying the tool and then just having to regenerate the tool paths.
Alrighty, great.
Okay. Could I add something to that?
Sure, please go ahead, Scott.
If they're talking about a time in cut, so that at a certain time they could then retract and check the tool, we don't have that capability in our system. In other words, after a certain time of cut, retract, check the tool, we don't have that capability that I know of, if that's the question.
Okay, great. Now we're going to move on to our last question here. How can I prevent RhinoCAM from running out of dynamic memory?
Well, good question. So if you're working on a 64-bit machine, you would probably wouldn't run into some of these memory limitations, which are due to 32-bit Windows architecture. So if you're working with large models, you may want to consider breaking them up into multiple chunks so you can program them like in sections. If you're having a 64-bit machine, you should be able to address large data sets. And hopefully that should take care of the dynamic memory.
Okay, great. Well, thank you very much, Uday, for the in-depth look into RhinoCAM as well as helping us with this question and answer time. Unfortunately, this is all the time we have for questions right now, and we do thank everybody for all the questions that you've asked. We are going to put together a blog post with all the questions and answers that you can go in and look at on our blog, along with the recording of today's webinar. A couple of things I'd like to mention before we part today is you can learn more about RhinoCAM by visiting rhinocam.com. And of course, if you'd like to learn more about Rhino, you can visit rhino3d.com. And this was mentioned when you registered for the webinar, but we actually have a special discount available for all of our North American users. We're calling that the webinar special. And so if you'd like to find out more info, you can give us a call at 949-654-8163. And also there's a link to the discount form in the email you received after you registered for the webinar. And mentioned this before many times, but today's webinar has been recorded and it will be available at mexoft.com/blog. I had posted the link in the chat that'll go directly to the post. Right now it says that it's not available, and that's because we haven't posted it yet, but that's the page that it will be available as soon as tomorrow. And then again, feel free to follow us and like us on Facebook, Twitter, and YouTube. We tend to mention our webinars first on our social media outlets, but before mentioning them anywhere else. And you can find product sneak peeks there as well. Before we wrap up, is there any closing thoughts, Uday or Scott Davidson, that you'd like to mention to everybody? Any closing thoughts about Rhino or RhinoCAM? Anything? All right, I'll take the non-response as a no. But thank you, everybody, for joining us today. And we look forward to having more of these webinars in the future. And feel free to visit mexoft.com/blog to be able to view the recording. Alrighty, thank you very much.